In this demo, we compared our planned competition drone to a larger drone by matching their power draw. The demo drone used larger propellers, so we expected a greater lift. Its total lift was about 2,900 grams, including the container, weights, battery, and the drone itself, meaning each of the four motors supported roughly 725 grams of thrust. Our goal was to test the feasibility of our planned drone design, lifting the competition's astroduct. In the competition, our drone will weigh around 250 grams and lift a 56-gram astroduct. So each motor must produce about 76 grams of thrust. The motors we plan to use can generate up to 180 grams of thrust at full throttle, which gives us plenty of margin. However, ideally, we would want to hover around 60 to 70% throttle to keep headroom for stability and control. The demo drone's 10-inch propellers have more than 5 times the amount of propeller area than our 2-inch propellers. But thrust doesn't scale linearly with area. It scales roughly by the cube root of the area. So in theory, that difference should only yield about an 84% increase in thrust. Yet we observed nearly a 300% increase in thrust. We believe this performance difference is due to the fact that both the 10-inch and the 2-inch propellers draw roughly the same amount of power. However, our smaller propeller must spin at a much higher RPM to absorb that power. Higher RPMs create greater aerodynamic drag losses, and since our smaller propellers also have more blades, those losses are compounded. Large propellers move more air slowly, which is more efficient, whereas small propellers move less air quickly, which is less efficient. Overall, we can make a reasonable engineering assumption by linearizing the relationship between the throttle percentage and thrust, and by assuming similar motor characteristics between both propeller motors. Therefore, since the demo drone at 70% throttle could lift a payload roughly equal to its own weight, it's reasonable to expect that our planned designed smaller drone, operating at a 70% throttle, can lift a payload that's approximately 24% of its own weight.